Hello, in this video let's discuss a question on DP on trees. There is a tree with n vertices from 1 to n. The ith edge connects AI and BI. Define the distance between vertices u and v as the number of edges in the path with endpoints at u and v. This path is uniquely determined as this is a tree. Solve the following problem for 1 to n. Among the vertices 1 to n, output the number of vertex that has the maximum distance from the vertex v. If there are multiple vertices that satisfies the condition, output the vertex with the largest number. Both n is up to 5 and both are up to n. The graph is the tree and all the inputs are integers. So the question is saying that we have to find the largest vertex with maximum distance from v. So firstly, let's take an example. If we have 1 2 3 something like this, what is the largest vertex at the largest distance from 1? It is 3. For 2 is this is also 3, and for 3 what is the answer? For 3 it is 2, because this is the one with the maximum distance and there is only one node with maximum distance, so that is the answer. If there are many, we have to print the maximum value among all the nodes which are at maximum distance from that node. So for this it is 332. Now the first thing is we can do NBFS, 1 BFS for every node, to find the largest node with largest distance, but that will be n square and that will give daily. So how to find the answer in O of n? So if we are thinking, so let's leave the answer for all. Let's just try to find the answer for some vertex v. So if we find some strategy v and if we try to apply them for all, if that reduces to often, then it is fine, right? So firstly, let's forget about the fact that we have to return the answer for all. Let's just think about some vertex v. So if we are thinking with respect to v, then let's root the tree under it. So for example, if this is the vertex we are thinking, this is the v and v. There are two cases. Let's come for the first one for now. So if this is the tree and we rooted at v, so how the diameter can be in the tree? So if we take a v, it can pass through v or it cannot pass through v, right? So in the first case, let's assume that it is passing through v. So this is the diameter and this is the largest one, so this passes through v. So this is the first case where diameter will pass through the vertex v that we are considering. So if that is the case, then we comment anything. Then we can say that the largest the node which is largest will either be this or this, right? Because this is the diameter and this is passing. So if that is the case, then we can say that this node or this node is the node which is at largest distance from this. Why? Because for example, let's assume that there is other node which is at larger distance than any of these. So let's assume that this is the node P. So this is the node P which is at largest distance from V. So if this is the case, then why this will be diameter? Then this and this will be diameter, or this and this will be diameter, right? Because this is the root and these are three kind of leaves. So if this is the largest leaf, this is the leaf with largest distance, then this will be in the diameter for sure. If this is the largest one, how can this be diameter then? Right? So from this we can understand that if v is the root we are thinking about and we got a diameter PQ, let's assume that QR. So if we get some diameter and if the diameter is passing through V, then we can say that either Q or R is at the largest distance from V, right? So this is the first case. And coming to second case, what if V is not passing through the vertex V? What if the diameter is not passing through vertex V? Then what is the case? So even then, so this is the diameter, right? So let's assume that now P is the node which is connected to V by a simple path, and then it passes through the diameter. For example, let's assume this is the diameter and this is the node. So this is the node and so this is the P, right, which is in the diameter and which is nearest to the V. So we can say that this is the nearest to V, right? Because if we come to here, this distance plus 1, even if we come to here, this distance plus 1. So indirectly P is the node which is nearest to V, and that is the diameter. So if that is the case, now can there be a case where the distance to any other node, not this and not this, and the distance is maximum? So let's check, right? So for example, let's assume that there is some other node, other leaf node with when rooted at P. So if that is the case, so let's assume that there is some another vertex which is a leaf node under the tree rooted at P, and that is the largest distance. So for example, this is the largest one, right? So now this is the largest one. So if there is a vertex Q which is not the boundary of diameter and which is rooted at P. So if that is the case, then even now we can say that this is wrong, because if that is farthest from P, right? If that is farthest from P, then why other two nodes will be in the diameter, right? So even then, if there is another node with largest vertex as Q, then the diameter will pass through Q for sure, right? Else this will not be diameter. So even now we can say that there cannot be a node under P which is same as diameter, like which can exceed the largest distance from V to any diameter. So this is not the case. And what if there is some other node which is not in the subtree of P but in the subtree of V? So now let's assume that this is the largest one, right? Let's assume this is R. So if there is some node R which is at largest distance than V than the normal diameter, so even now this is the case, right? So why R will not be in the diameter if that is the largest? So from some examples we can clearly get that for vertex V. So for any vertex V, if we get a diameter, then either the boundary of the diameter will be at the maximum distance from the vertex V. There can be many diameter, so there can be many vertices with maximum distance. But if we take any diameter, like if we take all the diameters, if we club all the nodes which are at boundary, then from any vertex V, those are the only possibility of nodes for which we can get the maximum distance from V, right? Even for the case 1 or even for the case 2. So hope you get this. So what is the fact that we can conclude? So we can conclude that for any vertex V, the farthest vertices are the boundary nodes of any diameter, right? So we can use that fact here. Now the thing is, it is given that if there are many nodes with the largest distance, we have to find the one with the largest node, like with the largest value. For example, if you have 3 nodes, 3, 5, 6 with all as with ending as diameter, then we have to return 6 if all of these 3 have the same distance from the vertex V that we are considering. So now how to find it? So let's find the diameter. So here the main thing is to find the diameter with largest vertices, right? So that if we just find one diameter, based on that we can find the answer. So instead of finding all the diameters, we can find one diameter effectively with given condition. What is the condition? So given condition is we have to find the largest vertices also with the largest diameter considering. So when we are considering the largest, like when we are considering diameter, we can think to find the diameter with the nodes as largest node, so that these both conditions will be effective in one diameter, right? So if we find one diameter with net condition, there is no need to think about other diameters, because in this diameter itself we concluded, like we added the maximum node also, right? So now the main thing is to find the diameter with this condition. What is the condition? To include the node with the maximum number also if there are many such nodes. So let's do it, and then it will be simple. So now, so how to find diameter in tree? So simply we can do BFS from any node. So let's assume that we are doing from BFS from 0. So if we do BFS from 0, we will the largest node, like the node which is farthest from 0. Let's assume that is P. So this is P, right? And now we will do BFS again for P. so that we will get the largest node from Q, largest distance node from Q, from P. So this is Q. So then that will be diameter. So this is the normal way we find a diameter. We discussed in the previous videos. So now, can we follow the same? So if we follow the same, then how can we how can we add the fact that we want the largest node if there are many nodes in the diameter? So we thought that we have to add that, right? So how can we do? So let's check that. So the first thing is, so what is the largest node in the tree here? It is 9, right? So can we include 9 in the diameter because this is the largest node? Absolutely no, because there is no guarantee that 9 will be in the diameter, right? 9 is the largest vertex, but we have to return the largest vertex only if that is in the diameter. We should not blindly return 9 if it is not in diameter, right? So we cannot think about 9 in the initially, because 9 cannot be in the diameter, because this can be a case. So this is the 9 and this is the diameter. So if this is the case, then this and this are the boundaries of diameter but not 9. So simply we cannot think about 9. So 9 is not priority here, because we can make priority 9 if we know that 9 will be in the diameter, but we are not sure initially if that is the diameter or not. So simply now what we will do, so even now we will do the simple BFS, but now we will update the value answer if there are many nodes at the higher distance from now. So if there are many nodes in the higher distance, then we will update the answer to the node with the maximum value among all the nodes which are at maximum distance from the node. So hope you got that. We can understand more from the code. So from this what we got, so from 0 we will get the node with highest value, and that is also diameter, and we will find the other node in the same way for 8. So we'll get other vertex 9. So 8 and 9 are the part of diameter, and this will also include the largest value if there are many diameters. So let's check the code for that, and now we will get the diameter. And now the next thing is, we have to find the node which is farthest from every node, right? So we got the diameter, and now we have to find the maximum, we have to find the node which is at maximum distance from every vertex. So how can you do that? So even now if we observe, we have to do some kind of BFS for every node. Is that true? No, because we can simply do the BFS from 8, 9, and then we can find the answer for all the nodes, right? Because we will do BFS for 8, and we will store the distance from every vertex to 8, and we will store the distance from every vertex to 9, and then we will loop through all the nodes, and we will find the distance to 8, we will find the distance to 9. If these both are not equal, we will return the node with we will return the node with that value. And if these both are equal, then what we have to do? Then we have to return the maximum value of those both. So in this way we are able to find the answer in half n. Let's check the code. So firstly, input the values, and then so now we have to find the end, the edge of the BFS, right? So firstly, int x is equal to function 1 of 0. So we are doing BFS for 0, and x is the largest, x is the vertex that is farthest from x, and if there are many, it will find the largest one. So how to find the function 1? So initialize the distance vector n plus 1 comma minus 1, and now push the starting into q, which is initially 0, and distance of 0 equal to 0, and initially answer is 0. And now do the BFS, and then pop the node, and update the answer only if the distance of x is more than answer. So answer is the answer till now, and x is the node which we are doing BFS for now, which we popped from now, right? So if the distance is more, or if the distance is equal, and if the node is more than the present answer node, only then we can update the answer to x, right? So in this way, at every level we will update the node with the maximum value. So in the first BFS we will update the first one, and in the second BFS we will update the answer among second level if there are many nodes, and final. So in this way, after completing the whole BFS, we will reach with the highest node in the last level, right? That is what we exactly want. So update the answer only if the distance is more, or if the distance is equal and the value is more. And now simply do the BFS, push the value and then like increase the value and then push, and simply return answer finally. And now we will get the answer for 0, and similarly find the answer for x which we returned here. And then so now initialize the values d1 and d2. So now we have to find some kind of BFS distances for every value. So function of 2 will return the distance vector, the distance from the vertex to every other vertex in the tree. So this is also exactly same. Do the BFS, and if the distance is -1, add the distance to 1 and then push in the queue. So after finally returning, what we'll get, we will have a distance vector that represents the distance from the starting node to every other node. So after these both, so after function 2 and function 2 of y, we will get 2 vertices. And now this is the ultimate answer, and increase the vertices because this will return in the 0 based indexing, but we have to find the answer in 1 based. So simply increment the values and then loop through all the nodes. And if the distance 1 is more than distance 2, what it means? It means that x is farther than y. So if x is farther than y, answer is equal to x. If d2 is more, then answer is y. Else we have to find the maximum value, right? So simply max of these both, and finally return, like print the answer. Hope you got this. If you have any doubts, comment below. See you in the next video.